Okay, this is my homework for assignment 6. This is problem 1, which uses this data set to solve those two problems right there, which is piecewise linear interpolation and quadratic interpolation, those 3 ways. So I'm going to start with the by hand computations. So if we start here with the linear, there's the linear form right there, that y of q. I then wrote my data set up top. The red underlines is for x equal to 0, and the blue underlines is for x equal to 1. So my x equal to 0 right here for linear, I got 0.9667 for my y of q, and x equal to 1, I got negative 0.888 for my y of q. And then quadratic, it's just the linear formula with the addition of this quadratic term right here, introducing that third value of x and y. And once again, I wrote down numbered everything for x at 0 and x at 1. So y of q at x equal to 0, I got 0.7747. And then y of q at x equal to 1, I got negative 1.301. So now if we move back to my computer and I go to my assignment here, we can start with 1.1, the piecewise linear at x equal to 0 and x equal to 1 with the graphing. So if I run that, pull up this graph, you get this linear formula right here. And then if I get as close to as possible to 0 here, just by moving that a little bit more. Yeah, you see 0.721 for that y value at 0. And then if I move over here to 1, I got negative 0.04. But here, if I can move, yeah, around there is that value. Or here, I should probably read it out. So like negative 0.04 to negative 0.058. And then here is the interpolating linearly at x equals 0. So if I run that, hit enter, and then my y of q is about 0.7294 there. With that code, which is just my data set my x of q, polyfit it to a linear formula, and then polyval to get the value. At x equal to 1, it's same thing, set the data set my x of q equal to 1, polyfit it linearly, and then polyval to get my value. And then if I run that, it's about negative 0.0467, which is pretty consistent with my graph. And then quadratic interpolation, I wrote out this code. I used scatter here to make sure that my polyfitted and polyval plot actually matched up with the data set. And then I just used x of q equal to linspace, and then set my window to be big enough to show me both points at which I need them. Polyfitted it with a second order to get a quadratic, polyvaled it, plotted both the x of q and y of q. And then if you run that, you get this graph right here, which at 0, let's see how close I can get, about 0.889. And then at 1, about negative 2.46. So, and then here's my quadratic interpolation without the graph. So I just used my data set my x of q equal to 0, polyfitted it with a second order, equation, and then polyvaled it with x of q and p. And if I hit that, enter, I get, oh wait, I did not hit, I hit alt, control, enter, should run the code. You get 0.7747, which if I go back to the graph, go to 0, it's pretty close. If we were to get even closer to 0, it'd probably be about that. Yeah, because up in that barely negative, about 0.889. So yeah, that's pretty close. And then here, if we go down here, it's the same thing, except change my x of q equal to 1. And then that changes my y of q to negative 2.47, which if we go back up to the graph again, run that, go down here to 1, is pretty spot on. Okay, and that's my homework.